Welcome back. I hope you've had a chance to do the practice, and here are the answers to the practice. So please check out your answers. If they look good and you don't have any questions, then please move on to the next section in the Nearpod. Take care of the next topic. If these answers don't look like yours, or you have a question, please stick around and we'll work them out together. So I'll give you about another half minute to check your answers with these that are here. And now we're moving on. So, it's about the sum and difference of two cubes. On number 1, do we have two cubes? Well, yes we do. This has got to be the cube on x minus the cube on 64 is 4. Because 4 times 4 is 16, times another 4 makes 64. So now we can factor. Our first factor is just going to be basically this. Cube root of x cubed, subtract the cube root of 64. Then here we're going to have 3 spots to fill. We'll figure out what goes in the front, what goes at the right, and then we'll figure out the middle. So in the front, it would have to be whatever we take times x to get x to the third. Well, that's x squared. Over here at the right, it would be whatever we multiply times -4 to come out to -64. Well, 4 times 16 is 64. So we know this is a 16. But if we start with a negative, we multiply and end up with a negative, this has to be a positive 16. -4 times positive 16 makes -64. And then in the middle, we go back to the first factor, multiply these together and change the sign. So they multiply out to -4x, but we'll change the sign and make it positive 4x. And that's the factorization. We couldn't do this if this was the difference of two, sorry, these were perfect squares, but we can with perfect cubes. You can do the factor the sum of two cubes. So this is, of course, the cube on x, plus 27 is just the cube on 3. So our first factors just going to be the cube root of x plus the cube root of 27. And then for our trinomial, to get from x to x cubed, you'd have to multiply by x squared. At the end, positive 3 times what makes positive 27? Well, that would have to be a positive 9. Then to get the middle, we're going to multiply these two together and change the sign. So 3 times x, change the sign. And we're all done with that one. The next two are a little trickier. To be perfectly honest, if they had given us -a to the third plus 8, I would just use the commutative property and rewrite this as x minus a to the third. And then we have the difference of two cubes and we can go ahead and proceed. But they didn't give us that. So we can't do that. In the last lesson, you reviewed greatest common factor and how you can pull out the greatest common factor. Well, we do have a common factor here. We have a common factor of -1. And if we factor it off the first term, that would give us a cubed. And then if we factor -1 off the -8, that would give us a +8 here. This is the same thing as that, but now we've got the sum of 2 cubes. So we can continue the factorization. We will bring down the -1, it's still part of the problem. And then the cube root of a cubed is just a, plus the cube root of 8 is just 2. And we'll have to find the trinomial. To do that, we're going to use this, not the original, but this with the -1 taken off of it. What do we need to multiply times a to get a to the third? Well, that's a to the second. Down at the end, what do we multiply times +2 to get +8? Well, that's +4. And in the middle, we're going to multiply these two together and change the sign. So 2 times a, change the sign, and we'd be finished. Now you may wish to multiply the -1 here. We would not multiply it times the second factor. That's okay. In calculus, though, they would consider this line here as the complete factorization. Moving on to the last one. This isn't a perfect cube. This one's not a perfect cube either. We need perfect cubes. But maybe this greatest common factor deal will work for us again. Are there common factors between these two? Well, they do have an x. We can pull an x out of this one and a factor of x out of that one. And the coefficients on each one of them are even. So we can at least pull out a 2, maybe a 4. I'm going to start with a 2. So if we pull 2x out of this, we'd need 125. And pulling the x out, we'd need an x cubed. So these two would multiply out to that. And then to pull the 2x out of the second term here, we need a 64. And we don't need an x because we already pulled out the only x there was. Well, this, my friends, is a perfect cube. And we already know that 64 is a perfect cube. So we can keep this factorization going. We can keep the 2x. And then we're going to have a small factor and a trinomial. Cube root of 125 x to the third. Well, that's 25. No, it isn't. It's 5x. Sorry about that. Plus the cube root of 64, that would be 4. Then we need to complete this. What do we multiply times 5x to make 125x to the third? Well, to go from 5 to 125, you need a 25. To go from x to the third, you need x squared. Down at this end, what do you multiply times 4 to get a 64? Well, you'd have to take +4 times +16 to get a +64. And then in the middle, we multiply the two terms here together and change the sign. So 4 times 5x is 20x. Change the sign, -20x. And except for the mistakey here, that's the factorization for the original problem. And it's time to move on to the next topic.